Friends, welcome again. Today we'll be solving a problem related to commutation, and the problem is there is a 4-pole lap wound DC machine, and it has a armature current of 10 amps which has to be reversed. Okay, this thing you have to keep in mind, it has to be reversed. So 10 amps has to be made minus 10 amps. Okay, if you consider one as plus 10 amps, and he is saying it has to be done in 5 milliseconds. Okay, the commutation time also has been given, that is 5 millisecond. The inductance of the coil is 1 millihenry in each parallel path. Then what is the inductive kick? So inductive kick means the voltage that occurs due to the inductance of the coil while you are reversing the current. Okay, so what happens in commutation? Okay, if you visualize it, what happens is the current, okay, the current, it suddenly reverses. Okay, because we want DC current at the output, or because of that the current has to reverse, so 10 amps has to be minus 10 amps. Okay, due to the commutation action. Okay, now this is the time which is given to us. Okay, this time is 5 millisecond. Okay, this is already given to us. Now what we can do here is we can first visualize what is a lap wound machine. We already know that A equals to P equals to 4 in lap. Okay, number of poles will decide the number of parallel paths. So here it is 4, so number of parallel paths is 4. So there are 4 identical parallel paths which are shown here. Okay, now you can see that the armature current is 10 amps. So for each parallel path the current that is flowing is 2.5 amps. Okay, because it is 10 by 4, so each parallel path has a current of 2.5 amps. Now what you can see is the inductance of the coil is also given to us. Okay, for each parallel path. Okay, so for each parallel path the inductance of the coil is 1 millihenry. Okay, so now what we can do is we can name this one parallel path as path 1. Okay, path 1. So for path 1, if I write for path 1, inductance is equal to inductance of coil. So there will be many coils, so the inductance, total inductance he is saying is 1 millihenry. Okay, now current flowing, okay, through coils is equal to 10 by 4 is equal to 2.5 amps. Okay, and now what we know is we have to reverse the current in 5 milliseconds. Okay, so let us see. We know that voltage induced is equal to L into rate of change of current. Okay, now 2.5 amps is flowing, so 2.5 amps has to be reversed to minus 2.5 amps. Okay, so net change in current is equal to, this is called DI, I can say this as DI, or that is equal to, we can say it as delta I also. Okay, because let's say it's linear, so it's delta I, so that will be equal to 2.5 minus of minus 2.5, because the end current has to be minus 2.5. Okay, okay, so this if you do, it will come out to be 2.5 plus 2.5, which will be 5 milli 5 as ampere. Okay, this will be 5 amperes. Okay, now you have got di, you know that your dt, or you can call it del t here, which is given as 5 milliseconds. So I can write 5 into 10 power minus 3 second. Okay, now we have both di and dt, and we have the value of L. So V is equal to L. L is given to us as 1 millihenry, so it is 10 power minus 3, okay, into di. Okay, so di is given to us as 5 amps, okay, over dt is 5. Okay, now if you do this calculation, it comes out to be 1 volt. Okay, so the voltage induced will be 1 volt. Okay, so all the four uh, coils are in parallel, so the voltage induced across these two terminal, if you say, because of the inductance of the coil during commutation will be 1 volt. Okay, so thanks for watching.